Alright, so in this video, let's look at the E climate zone as well as the H standalone climate type. Alright, so within the E climate zone, we have two specific climate types, tundra and ice cap. Now, what they share in common is that no monthly mean temperature can exceed 50 degrees Fahrenheit, because it's at that particular mark that if temperatures do exceed 50 degrees Fahrenheit, that is warm enough, even if it's a short period, that is warm enough to support forest growth, tree growth. And so for both tundra and ice cap, you can't have trees, Now, what separates the two is that tundra is, what does it say, cold, while ice cap is consistently very cold. Okay, so for tundra climate type, lettering convention, uppercase ET, at least 1 month must exceed 32 degrees Fahrenheit. In other words, at least one monthly mean temperature must exceed the freezing point. And so even though that is not warm enough to support forest growth, it is warm enough to support vegetation growth. And so the dominant vegetation type within the tundra environment tends to be lichens and mosses, like what you see here in this particular picture. Now, tundra climate type tends to be found in peripheral areas of the Arctic, okay? So we're looking at the periphery of Canada, the periphery of Russia, peripheral areas of Greenland, by which, even though it's cold as it sounds, at least it's warm enough for a short period of time to support some vegetation. And so thus we will have often some wildlife. If you look at our megafauna, like polar bears here, and then the animals that they feed on, like a lot of the marine life, seals and all that, it's warm enough to support them. And the reason why it's warm enough to support them is because of that peripheral location, being close to water. Even if it's an extremely northern latitude, being close to water will at least provide warm enough temperatures to have that vegetation and to be able to support those fauna. Speaking of the fauna, speaking of the animals, animals of the far north tend to have very short appendages, very large torsos. This is to help conserve heat. And in fact, even if you look at people with very northern ancestry tend to have longer arms, longer legs, larger torsos, but more compact torsos, because it's a way of conserving heat, as opposed to many people who come from equatorial parts of the world, or their ancestry is of low latitude parts of the world. Their appendages, their arms and legs, tend to be a little bit longer, and their torsos tend not to be as large. Now, the tundra environment is not as cold as the ice cap or ice sheet environment, because in no month does the average temperature exceed the freezing point. So as a result, you have permanent cover of ice and snow. Because high pressure dominates in these parts of the world, much of Greenland, most of Antarctica, because high pressure dominates, precipitation totals tend to be very, very low, well below 10 inches and often below 2 inches. So technically, that's why I described Antarctica technically as a desert before, but it kind of depends on your definition of what a desert is. Within the ice cap environment, there is no vegetation because no monthly temperature exceeds the freezing point on average. All right, now the highland environment, H, just as a standalone climate type, is found obviously in places of high elevation. Typically, we're looking at least 10,000 feet above sea level, 12,000, 14,000 and upward. So we're looking at the extreme highlands of South Central Asia, the Himalayas, the Karakoram, the Hindu Kush mountain ranges. We're also looking at the Andes of Western South America, the highest of the Rockies, the highest of the Alps within North America and Europe, respectively. Okay, so a couple of concepts I want to bring up here with the highland climate type. Considering slope aspect is very important. In other words, in which direction do certain slopes face? And so in the northern hemisphere, if you have an east-west trending mountain range, the slopes that face the south tend to be warmer, tend to have more vegetation, and tend to have more population because they're facing the sun throughout most of the day. You know, if I always like intertwining cultural geography with physical geography. If you're familiar with the concept of yin and yang, or yin and yang, the yang part refers to the white or lighter shaded area of that circle that's interlocked with the darker shade. And so when it comes to religious philosophy, we'll say in much of Asia, the yang or yang is often connected with the southern facing slopes, those that are exposed to sunlight during much of the day. So whenever you model for just outside of that topic here, whenever you model for landscape change or temperatures, you forecast for the weather, slope aspect is a very important consideration. Another thing I want to bring up here is the concept of vertical, also known as altitudinal zonation. So what this means is that traveling upward just a few thousand feet can be the equivalent of traveling thousands of miles in latitude, you know, like from an equatorial location to a mid-latitude location to an Arctic location. And so let me bring up the Latin American template to help illustrate this point. So for example, if you look at your highland regions of Latin America, within a couple thousand feet of sea level down here, you have a very tropical environment, especially if you're looking at a low latitude location near the equator. So typically within this lowest zone, referred to as tierra caliente or hot zone, you have plantation crops. You have, you know, things like chocolate and bananas and different types of fruits and sugarcane being grown. Within moving upward, maybe 5,000 feet, 7,000 feet, 8,000 feet above sea level, you have tierra templada, which means the temperate zone. You're high enough by which even if you're relatively close to the equator, highs might be in the 60s or 70s, lows in the 40s or 50s. Many of your large Latin American cities are actually built within this templada zone, the temperate zone. Moving upward, maybe 8,000, 10,000, 12,000 feet above sea level, you have tierra fria, the cold zone. Usually it's within this zone that population starts to drop off. You have more mid-latitude crops that may come to dominate, like potatoes, wheat, sturdy crops that can withstand the colder and drier conditions. One thing I forgot to mention with templada, the temperate zone, is that, you know, think of it as being like a mid-latitude location like Indiana. So as you see in this particular illustration with corn, beans, and squash right here, you know, these are things that can and do grow well in the mid-latitudes, but within low-latitude environments, they can thrive as well, as long as you're looking at a pretty decent elevation. Nonetheless, ranging upward to the highest zone here, tierra helada, which means frozen zone, here is where you don't find many activities, maybe a few grazing animals, but conditions are pretty consistently cold, and so therefore it's difficult to support both population and agriculture. And then eventually you have the snow line. And so in this particular template, you know, the Latin American template, you know, a very large city within Latin America is Bogota, Colombia. It's about 8,000 feet above sea level, 8,000 feet plus. It's in the foothills of the Andes that you see here to the west or on the left-hand side of this picture. But it's very common for many cities of Latin America to be established at a relatively high elevation because in the Tierra Caliente, closer to sea level, it's too consistently hot and humid. They're usually inundated with, you know, not only literally inundated with water, but inundated with insects, with mosquitoes, you know, major issues today, and especially historically with yellow fever, malaria, and so forth. All right, now let's move on to our last set of topics, but let's save that for the next video.